Hi guys, today we're going to go through some motion problems. A jet aircraft is taking off from an international airport. Its mass, including passengers and fuel, is 150,000 kilograms. Its takeoff speed is 100 meters per second. Okay, and the maximum thrust of the engines is 500,000 newtons. Using the equation for kinetic energy in joules, half mv squared, calculate the kinetic energy at the moment of takeoff. So we need a half times the total mass, which is 150,000, times by the velocity squared, so that's v, and then times it again, and that gives us 750. 1, 2, 3, 4, 5, 6. 750 million joules. Alice pulls her brother Simon on a sledge. She pulls with a force of 100 newtons and the frictional force between the sledge and the ground is 20 newtons. So what's the resultant force on the sledge? Well, we have to add the forces together, but the force on the sledge and the ground is in the opposite direction, so it's going to be a negative. So we're going to have 100 minus 20 is equal to 80 newtons. How much work does she do in pulling the sledge 20 meters? So work done is equal to the force times by the distance. So that's going to give us the force, which is 80 times by the distance s. So 80 times by 20 is 1,600. And work done is measured in joules, so we just need to put a J there. Michael Johnson won the 200 meters at the 1996 Olympic Games with a new world record time of 19 seconds 32. Write down the equation you could use to work out his average speed in the race. So that is speed equals distance divided by time. Calculate his average speed. Okay, well the distance was 200 divided by 19.32. Let me just do this in the calculator. So 200 divided by 19.32, we get 10.35 meters per second. He reached a velocity of 7.5 meters per second 2 seconds after he started the race. How far had he run in the first 2 seconds? And you assume he accelerated at a constant rate. So how far did he run in the first 2 seconds? Well, if I just draw a velocity time graph, he's starting off from 0, so there's v, there's t. So he reaches a maximum speed of 7.5 in 2 seconds. Now for a velocity time graph, the distance travelled is the area under the graph. We've got a triangle here, it's going to be a half times the base times the height. So we've got 0.5 times by the base. Well, it took him 2 seconds, so that's going to be times by 2. What was his maximum? It was 7.5. So 0.5 times 2 times 7.5. Well, there's the half and the 2 cancel, and it gives us 7.5 meters. In the 1996 Olympic Games in Barcelona, Linford Christie won the 100 meters race with a time of 9.96 seconds. Write down the equation to calculate his average speed. Well, just like before, speed is equal to distance over time. Okay, calculate Linford Christie's average speed for the 100 meter race. So 100 divided by 9.96. Okay, let's do that in the calculator. 100 divided by 9.96. That gives us a speed of 10.04 meters per second. In the 1896 Olympic Games in Athens, the 100 meter race was won by Thomas Burke in 12 seconds. Calculate his average speed. So we're going to do 100 divided by 12 So 100 divided by 12, we get a speed of 8.33 meters per second.